Hi, everybody. Welcome back to the Chicago Math Practice Lab, Learning Through Practicing. Okay, so today we're going to talk about the first practice set for the limits. And this will be pretty easy one. So we start from the very basic, is how to identify the limits if you give me the graph of functions here. So for this practice set, we're going to take a look at three functions here. So this is the first functions. And then we have several limits we want to find. Then here is our second function. We have several limits we want to find. And here is the third one here, okay? So should be a pretty quick unit. So right now, just like always, it's a good time to pause your video and try to do those problems by yourself. And then we will come back and check the answer. Okay, so I'm going to on the whiteboard right now, and I will see you, after you finish here, okay? Hi, I'm back in the whiteboard, and I kind of draw the pictures on the whiteboard, and of course it's not good as I have shown in the beginning, but I guess we can get an idea. And so it's easier for me to do the demonstrations here, right? Okay, so let's take a look at these ones here. Before we do, as always, let's do a brief review what is about the limits here, right? So the limits, we talk about the limits is when we said the limits x approach to a number like a, now what is this function values we're going to approach to? That's how do we define the limits. So when we approach to the a, we really have two ways to approach it, right? So we have this is, we said the limit approach to a from the, you have to see a positive sign. That means that you approach to the a from the right-hand side to see what is this limit. I call this is L1. So like in here, basically will tell you here if this is your functions, right? So this is a. So when you say the approach to from the A plus, that means you approach from the right-hand side here. So if the limit is L1, and then the next thing here is, of course, you can approach the limit from the left-hand side. But, so that means this is f of x if that has a limit equal to L2 here. So that means you approach the A from the left-hand side here. So the things here we said, hey, if the L1 equal to L2, then we say this limit exists, right? So we say if this is equal to each other, and then we say the limit exists here. And the limit will be the else here. And in here, right, so I see the limit definitions here is really, it's just like the left approach, right approach, they equal to each other. So the one thing we did not care, not to say we don't care, we not talk about is how about the f of a, the function values here, right? So the function values here, we don't really, the limits has, we don't really work with the function value. Said, hey, as long as you left approach, right approach, they equal to each other, then we said the limit is equal to the else here, and the limit exists. Then the function values in the later units when we talk about the limit and the continuity, we're going to talk about that. Okay, so now let's take a look at these ones here. So these ones here, the first ones here is x approach to 2, the negative sign. That means I'm approaching to 2 from where? From the left-hand side, right? So your function, when you approach to 2 from the left-hand side, so what is your function going to go to? So go to continue and continue here, right? So what is here? So your limit is equal to what? It's equal to 3, all right? So now the same way, so in here, if you say the limits continue from the 2, the positive signs here, right? So that means you approach to from the right-hand side here. So that means you see your function value and get closer and closer to. What is getting closer and closer to here? Close to 1, right? Because this is 1. And so because we know the 3 is not equal to 1, right? Because one way they approach to 3, one way they approach to 1. So what is the limit of x approach to, what is the limit of the x approach to 2 here? Because your right approach and the left approach, they are not equal to. So what in here we say the limit is what? Do not exist, right? Do not exist. So this limit is not exist. So sometimes you will see the people use DNEs. That means do not exist. Okay, so now the next thing here we talk about is the what is this F2. F2, like we talk about, is a function values, right? So this is a function values here. That means when the x equal to 2, what is your function value? So like in here, the x equal to 2 is here, right? So in here, there's a solid dot. So I know my function values here is equal to what? It's equal to 3 here, correct? Okay, because that's what, that's what is the function value mean. Okay, so now let's take a look at this one, x approach to 4, right? So let's do the left-hand side approach also. Here's the 4th, right? So the left-hand side approach, what I'm going to get here, so limit x approach to 4 from the left-hand side, f of x, going to give me what? You go like this way, you're going to have what? 4s, right? Okay, so now I'm color coding here. If I approach from the right-hand side, I'm going to approach here, right? So let's limit x approach to 4 from the right-hand side, f of x. What I have here, hey, I got a 4 also, right? So that means in here, 4 equal to 4. So that's why if the right approach equal to the left approach, then the limit exists. What is the limit here? Oh, I already wrote here is limit equal to 4 here, right? Okay, so now let's take a look at the last ones here. Last ones again, so what is this ones here? That's what is this one. This is the function values, right? That means when you x equal to 4, what is the x here? As you can see, when the x equal to 4, what happened here? Here is a circle. That means I don't have the values here. So this ones here is do not exist. You see here? So be careful about the notations, right? So the function value doesn't have to exist. The limit can exist. Remember, so that's why we say the limit exists. The condition is your left approach equal to the right approach. And the function value, whether the function value is equal or not, it doesn't matter. Okay, now that's good. Let's take a look at our next ones here. The next one, this one I really cannot draw very well, but in here you can reference back to the, to your handout, like for the front page, you should be able to, you should be able to see that. Okay, so now let's take a look here. Okay, so the first ones here is limit x approach to -3 from the, from where? From the left-hand side, right? -3 is here, so I approach to -3 from the left-hand side. So what is the limit going to approach to? It's getting closer and closer to what? Closer to 4, right? Okay, now I'm color coding here the same thing. If the limit approach to -3, the positive, what means the positive? On the right-hand side, that means my limit going this way, right? So what is the value going to here? It's a 4. Oh, you see the 4 equal to 4. So I know the limit when the x approach to -3 exists. What is the value? F4, right? Okay, good. And then now let's take a look. H -3. That means what is this one here? This is the function values, right? So the function values here, the f equal to h equal to -3 is a circle. So that means I don't have the function value. So what is here is a DNE do not exist. Correct? Okay, so everything is about the, it's very, so that's why for you to graph will give you some good idea about the limit exists and the function value. They don't have to be the same here, right? Okay, now let's take a look again. The next one's here. The x approach to 0, the negative sign, that means from the left-hand side. That means I'm approaching to 0, so I'm approaching to this way here, right? So what is the value here? The limit approach to 1. Okay, so now the same way, approach to 0 from the right-hand side. That means my function go like this way, go to the right-hand side, right approach. So what is the values here? It's a -1. Oh boy, here, right? So this is 1, and this is -1. It's not equal, correct? If not equal, what happened to this limit? Do not exist, right? So we say the limit exists. The fundamental is what? They have to right approach, left approach has to be equal. Okay, now take a look again. This is H0, doesn't have a limit in front of it. So what's that mean? That means it's the function value. So we look at H is equal to X equal to 0, right? So this is X equal to 0. So this is 0. So what is this value? Is 1, right? So the function value is 1 here. Okay, now let's take a look at the next ones here. Limit X approach to 2. Okay, limit X approach to 2. So it's in here. So let me write the 2. So I'll approach 2 from the left-hand side, right? So I can say the limit X approach to 2 from the left-hand side, H of X. What is this value? Is equal to 2. Correct? Okay, good. So the main limit, now the same way I can approach 2 from the right-hand side, so go approach this way. So limit X approach to 2 from the positive sign, H of X. What is this one equal to? Is equal to 2. So, well, 2 and 2, they equal. So what do we know about the H of X approach to 2? So it exists, right? Because right limit go to left limit. So what is the limits here? Is 2. Okay, so one more time. So what is here? This is the what? So this is the function value. So as you can see, when X equal to 2, what I have here, I have a circle. So that means the function value do not exist, DNE. Okay, so now the next ones here is limit H of X, from the phi to the right-hand side here, right? So that means I'm going to phi to here. So what is this limit going to approach to? Going to approach to 3, all right? So now in here, I'm going to approach to phi from the left-hand side from here. As you can see from the left-hand side from the phi, the graph is up and down, right? So it's kind of like a repeat up and down, up and down. So I did not see it going to go to certain value. It's kind of like the up and down. So this one's here, the limit is what? Do not exist here, right? Because from here, if you look at it, it's just like go like this, right? So that's why it does not go to any specific value. That's why the limit does not exist. So okay, let's take a look at our last problems here. So this one's here, it's just we try to take a look for the the indefinite limits here. Okay, so now let's take a look here, right? Now I'm going to find the limit X approach to what? -3. Okay, so when the limit X approach to the -3, let's still take a look at its limit X approach to the -3 from the left-hand side, AX. That means I'm approaching to from here. So what I'm going to approach to here become positive infinity. So the same way, like my color coding from the -3 to the right-hand side. So limit X approach to the -3 from the right-hand side, AX. What I have here, is infinity. So I have infinity over infinity. So do my limit exist? Yeah, it's infinity. Of course, infinity is not a value, so you can, so it is exists, so they both approach to infinities, right? Okay, so now let's take a look at the next ones here. The next one is, let's say, X approach to 2 from the left-hand side. That means from here, right? So I'm approaching to 2. That means my graph is going down here. So what is this number go approach to? Approach to what? Approach to the negative infinity. Okay, so now the next ones here is X approach to 2 from the positive side or from the right-hand side. That means I'm approaching to 2 here, right? So that means the graph is going here. So what is the limit here? It's positive infinities here. Okay, so now the next ones here is let's take a look, x approach to -1. So of course in here, because the right limit and the left limit when x approach to 2 is different, so that's why the limit does not exist, right? So the -1s here, right? Okay, -1, so the same way, let's take a look at the limit x approach to -1 from left-hand side, ax. That means the left-hand side, right? -1 is here, that means it's go down here. So what is here? Negative infinity. Okay, so now let's take a look. This is the limit x approach to -1 from the positive side or from the right-hand side is here, right? So the limit is going to what? Negative infinity. Haha, they are what? They are equals, right? So that's why I know the limit x approach to the -1 exists. What is that? It's negative infinities here. Okay, so now the part E, they're asking us to find the asymptotes here, right? So I have a few asymptotes here, right? So my asymptotes here, what is the first one? The first asymptote. So I have a few asymptotes here. So the first asymptote is x equal to what? Equal to -3. That means the asymptotes, that means they're going to get closer and closer to this line, but it's never touch that. What is the next ones here? Is this one is my asymptotes, right? So this is my asymptotes here, right? So this is my asymptote, this is my asymptote. So this is what? This is -1. And my another asymptote is here, right? So it's here. Even the limits not exist, right? So one is from right hand, go to the positive infinity, one is go to negative infinity. But this one is still is the asymptote. So this is x equal to what? X equal to 2. So for this graphs here, I have a total 3 asymptotes here. Okay, that's the first part of finding the limits, and this is very, very fundamental. By looking the graph, and then you can see how do we find the limits. So remember, the limit exists if the right approach and the left approach they have the same values here, right? So by the graph, and do not get confused with the function value. Function value is when x equal to that number, what is the function values here? If a function value is a circle, that means that the value not exists here, right? So yeah, so this will be our first practice set. Is it's a very basic set. So just look at the graph, and then you'll be able to determine the limits here. So our next set, we're going to take a look at indefinite limits, and we're kind of looking a little bit here already, but we're going to spend next video, we talk about how do I find the indefinite limits here. Okay, so that's it. So remember, right? Practicing, and practicing. That's the way to make you getting better in math. And thank you for watching this. And if you feel this is very beneficial, and feel free and to share to that with other people. Also, if you have questions, leave me a comment, and I will answer that. Okay, so thank you very much for watching, and looking forward to see you in our next videos here. Okay, bye.